So did you learn anything from this little tool up here? The question being, how is it possible, for example, for Minnesota to have the lowest average among white students and yet the highest overall average? Or for Texas to have a higher average in each racial category than the other two, but to have a lower average than both of the other two overall? So why is it possible? How does this happen? What makes Simpson's paradox work? Kim Terrence Catch.
You need to weight differences by what percentage they represent.
Right, so there's the first observation, is that each of these overall means is really a weighted average. Weighted mean, whatever you want to call it. And those means are weighted by their respective proportions of the population. Okay, so there's your first observation. And how does that explain it? What specifically did you notice when you fooled around with those percentages? Yeah, Kim.
Well, so if you made the population, the minority population in Texas smaller, the mean goes up because there's a higher population. Currently, the mean is being pulled down by the larger population, minority population.
Right, so you're looking at this bubble here and saying, well, even though the average non-white student in Texas did better than in Minnesota and Massachusetts, there's so many more of them that in the weighted average, it artificially kind of lowers the total mean. So what did you do in this little interactive tool that told that story? What did you try? What did any of you try?
For the radial bar for Texas, closer to white, yeah.
So let's make Texas more white. Right. Oh man, I can't believe I just said that. So let's change the racial breakdown of Texas a little bit into a different hypothesized Texas. And if Texas did have a larger white percentage and a smaller non-white percentage, that its average would be up there with Minnesota and Massachusetts. Even though each group did better in Texas, the fact that there was a much different balance of those two groups in the weighted average caused a very different result. There was something else I saw. Kat, I think I saw you do this. So you took all of these sliders and put them all to 50% or whatever. Or equivalently, we could put them all to 0, or we could put them all to 100 or whatever. But if we were to just make it so that white and non-white were equal in all three states, then what do you see? Texas comes out on top, which you would expect based on the performance of each individual group, right? Because if every state is 50-50 or whatever, or if every state has the same proportion as every other state, then the weighted averages will follow the patterns of the group averages. And so it's only these kinds of imbalances, like we see when we take Minnesota and Massachusetts and make them as lily white as they are, for the most part, that we can see this reversal, the Simpson's paradox reversal. And to me, as I said, Simpson's paradox is one of these almost unintelligible results. It's one of the classic paradoxes in all of statistics and therefore in a lot of quantitative literacy. And if a simple interactive tool like this can help students to make sense of the statistical, the numeracy reality behind Simpson's paradox, I think that tools like this can have a lot of value in interrogating other phenomena. So how I built this tool is I actually use the Google Charts API. I don't know if any of you have experience programming with Google Charts. But the essence, I should include a link to the Mathematica site on this slide. But if you haven't seen it before, there are a bunch of wonderfully built out demonstrations on Wolfram's Mathematica website, demonstrations.wolfram.com. And those are all pre-built tools. For those, because they do have higher order functionality, you and or your students would have to download a plugin, a Mathematica Player plugin, which is free, in order to be able to use the demonstrations on Wolfram's site. But if you're proficient in Mathematica, that's another great way to build interactive graphs and tools. Also, highcharts.com is a slightly more friendly version of Google Charts API that you can use to build little tools like this. So if you have that kind of programming inclination, either Mathematica or HTML or what have you, but there's really a lot that you can do to take a graph, a table, a case study, whatever, starting from real authentic data and make it more interactive, not only to teach a lesson about the material of that case study, but also to get across some often very difficult messages about numeracy at the same time.